Chapter 6, Section 6.1, Linear and Non-Linear System of Equations. A part of this chapter has been covered in beginning or intermediate algebra, which is there are three methods to use in order to solve a system. System means when you have two equations. A pair of equations is called a system. Here, what is the solution when we ask you to solve a system, or what is the solution of the system? Solution of the system is the point of intersection of these two lines. These 2x plus y equal 5 and 3x minus 2y equal 4, both are a straight line. These two lines intersect each other at a point. The point of intersection is called solution of the system. So for instance, here, we're saying 2 and 1. Is this the point of intersections? In order to verify that, you need to take that and substitute on each equation. If these points satisfy both equations, then yes. Or the pair of 2 and 1 is a solution of a system. So one of the methods to use is method of substitution. So you have two equations here, both are a straight line. So the method of substitution is you find the y in terms of x from one equations, like here at the top one. If I move x to the other side, then y is 4 minus x. Then I take this and substitute for the y in this equation. And when I do that, make sure you understand there is a negative and you have to bring this negative and multiply. That gives you the value of x. When you find the value of x, then you take this and substitute in one of these two equations. It doesn't matter which one, either one, you give you correct answers. So you substitute that to find your y value. So this is method of substitution when you want to solve a pair of equations that both are straight line. And how could you tell? Because the power of x and y both are 1. The power of x and y both are 1, that is indication of straight line. Now, this is a case you have nonlinear system of equations. Linear equation is a straight line, which is this one. Nonlinear equation is when you are talking about the parabola or a curve. And how do I know this is a parabola or this is a curve? Because the power of x is not 1 anymore, it's 2. So if the power of x or y is more than 1, then that is an indication of a curve, not a straight line anymore. So here you have a curve and a straight line. And if to solve method of substitution, again from the bottom ones, we find y in terms of x and substitute the top equations. We end up having an equation like this. You could either use the quadratic formula or method of factoring. That gives you two values. So if you actually have a curve, if I have a curve and the line intersected, there are more than one point of intersection. This curve has nothing to do with that example. I just want to show you that if you have a curve, like in this case, the parabola and a straight line, when these two intersect, you have more than one point of intersection. So here, that's why you have two values of x. So for each value of x, you have the value of y. How do I find that? You take this x, and it's easier to substitute here. That gives you value of y. So you see there are a pair. There are 2 points of intersection. This is another example. It's very similar to that. Since I'm going to give you a copy of this document, you could actually review this. So this is an example of two lines intersect. This is example of a parabola and a straight line. This is example that parabola or a curve and a straight line do not intersect. Okay, so in this case, you should not have any intersections. They do not intersect. And this is an example that there is two. One is a straight line, x plus y equal to 1, which is this line. And the other one is y equal natural log of x. And that is the graph is this. These two intersect at that point. All right. So if you solve a system of two equations and you don't end up having any x or y value is unknown, that means they never intersect. So there is no solution. So solution again means point of intersection. One solutions, two solutions, none. And this example is for the one that we actually use in economics, that if you have supply, line of supply and line of demand, these two intersect at the point of intersection. They call it break-even point. And this is a formula for the cost, and this is a formula for the revenue. So when we ask you to find point of intersections, so break-even point or equilibrium point, sometimes they call it equilibrium point, that means you got to take equation of the cost and equation of the income and set these two equal to each other and solve it. That gives you the x value for this point. So again, one equation is equation of the revenue, one equation of the cost. To find point of intersections, you have to set these two equal to each other, solve it for the x. When you have the x, then you could take the x and substitute in one of these two equations to find your other variables. Good. So here, these are some of the homeworks. I have the solution here. One is the parabola. One is a straight line. We use method of substitution here, so you could follow. This is in case you have a circle and a straight line, again, 2 point of intersections. Both are a straight line, method of substitutions, also this one. And solution for these problems, they all are here. So you see one of them is a circle and the other one is the straight line. So what you do is you find x in terms of y and you do the substitution here. You have two values for y. You take each value and you substitute to find your x. They both are a straight line. So you should have just one point of intersections. Same thing here. So in this case, you have only one, and problem number 4, you have just one point of intersections. Here is a case number 5 is you have a parabola because power of x is 2 and a straight line. So you should end up having these 2 points, 0, 0, and -2 and 4. This one, e to the x, is easier to use the graphing calculator for number 6. Number 7, again, is very similar to number 5. You have the parabola and a straight line. Number 8, the break-even points, very similar to the example. To find a break-even point, you put the revenue and cost equal to each other, solve it, and that gives you the x. Now we go to section 6.2. Section 6.2 introduced the second method, which is method of eliminations. Method of elimination is more useful than substitutions. Like here, this one, both are a straight line. So we just add these two. When we add these two, positive 2y and minus 2y cancel. So you have 8x equals 16, x is 2. When you find the x value, then you could take this x and substitute in one of these two equations to solve it like that. So for method of substitutions, let's say you have two equations. You have 5x plus 3y equal a number here, and here is like minus x minus 2y equals something like that. If you want to cancel x, you multiply the bottom equation by 5. Why? Because then the top equation, you don't touch it. 5x plus 3y, whatever. Here, when you bring the 5 and distribute, then you have minus 5x plus 10y equal. See, then these two cancel. That's how to eliminate one variables. So let's say here you have 3x and plus y equal, and here you have minus 3x plus 3y equal a number. We don't have to multiply by anything because these two are equal and opposite. They cancel anyway. So that would give you the value of y, and here you have the numbers. What if you have like 2x plus, I don't know, 7y equal, and then 3x minus 5y equal a number? In this case, what you do, you interchange. You put a 3 here and 2 here. If you multiply the top equation by 3, remember you have 6x, and here you have multiplied by 2, you have 6x2. These two need to be equal and opposite. So you just put a negative before one of these two. So what you have here is minus 6x minus 21y, and here you have 6x minus 10y. See, then these two cancel. Okay, so that's what method of elimination is. Here, we didn't have to multiply by anything because 2y and minus 2y cancel anyway. Like this one, what you could do, there are two ways to do these problems. One is you put a 5 here and 2 here. I think that's what they're trying to do here. Or you could eliminate y here. Look, I have minus 4y and I have positive 1y. What if I multiply the bottom equation by 4? In that case, y cancels. Okay. And I think that's what they did here. See, then y cancel, and you solve the equation for x. So you have a choice, either cancel y and x, but it's easier to cancel y because all I need to do is multiply the bottom equation by 4. So, you know, this is again equation of two lines by eliminations. If you want to eliminate y, this is minus 4, this is 3, right? I multiply the top one by 4 and the bottom one by 3. In that case, you have positive 2y minus 2y, and then cancel. So you multiply the top equation by 4 and the bottom equation by 3. And then these two cancel and you solve. Okay. All right. So again, when you have two equations, these are a good example. Two lines may intersect at one point. So in that case, when you solve it, you have a variable. Two lines may be parallel lines. They may never intersect each other. Or it might be the same line. Like here, you know, 2x minus 3y equal to 3. What if you multiply the top one by negative 2? If you multiply the top equation by minus 2, you get this one. So this is a type of the line that both lines coincided or they overlap at many, many points. So there are many solutions in the case like that. Let's see if we solve this one, what we get. We multiply the top one by 2. So we distribute this. And the bottom one, we don't touch it. What happened is here, look, this cancel, this cancel. You have 0 on this side and 12 on the other side. If you come up with something like this, that you cannot find the x, but you come up with identity which is not true, then it would be the same line. Means two lines might intersect each other at one point, or they might touch each other at so many points. Look, they touch at many points. That's the case of this. If you come up with something like this at the end, which is not logical, like 0 equals 12 is not true, then is a situation that two lines touch each other at many points. So what's the solution to this? Infinite. Now, look at the other one example. Let's look at this example, the second one. I have 2x minus 3y equal 3, x plus 2y equal 5. Now here, to eliminate x, I multiply the bottom one by negative 2. Now you have the y. You substitute in one of these two equations. So x is 7. And then this one, the top one multiplied by 2. Everything cancels, 0 equals 0, okay? So this is a case that two lines have, as a matter of fact, this is a case that both lines are the same things. So I should correct that and say this one is that, because it's the same line. Look, if I take the top one and multiply by 2 or by minus 2, I get the same one. So this is a case of this, okay? And the other ones, this is case of that. So we should say like that. So you have one of these three conditions. You either have, you end up having something like 0 equal to 0, which is the same line, or you come up with actual numbers, or something which is not logical. Okay. Right. So anyway, so these are, and then these are examples are almost like, this is a good example of two parallel lines. See how at the end they call up with 0 equals something which is not correct. And example 7 is an example of many solution or infinite solution. Why? Because it's the same line. If I multiply the top one by 2, you get the same line. Two lines, when they are same, they touch each other at many points. Here, they don't touch, no solutions. Or they might just have one solution. Right, so these examples, the first one has the solutions. I have the solutions for you here. So you could actually go through all of these. Again, these are two straight lines. There is nothing to explain about these ones. Two parallel lines. So I have the answers, the solution for all. See, when you get something like that, no solution, because this might be too parallelized. And again, these are solution to some of these problems. I have it here. This is 6. Yeah. So I have the solution for all these. There's nothing to explain on this one. So this is the one, number 8 is the demand and supply. If we ask you to find equilibrium point or break-even point, you have to take demand and supply set it equal to each other and find the p-value. So that would be end of 6.1 and 6.2.